What's up guys, PJ here from 3D Printing Canada, and today I have something I'm really excited to bring to you. I'm going to show you how I took two hobbies and turned them into one. So I'm going to build this drone on camera for you guys and show you how it flies. Okay guys, now we're going to run down some of the parts I use in my drones and let you know what each component is for and why, show you the 3D prints, etc. So let's get down to the motors. This is the part that's going to make the drone go. Okay, I use RCN power motors. These are absolutely wonderful motors. They've been great to me. I've tested a lot, and these ones I find work the best. They are a premium product. So then we'll move down to the camera. Now this is an analog camera. There are digital setups as well, so that's something if you're just getting into drones, digital might be the way to go for you. It is a little bit more pricey, but definitely a better picture. So I choose to use the CAD-X Retel camera. I use the Rush Tank Solo VTX. Now this thing's capable of 1200 milliwatts, so good for long range, good penetration through trees and flying and stuff like that. Then we've got the Axi F7 stack. So this is really cool. This is actually something I was really excited to be testing here. Now the ESC and the flight controller are all built in. They've done some pre-filtering as well on the ESC, which is absolutely wonderful. And then everything's plug and play on this. So for beginners, this is gonna be a really good stack all around. It's gonna minimize all the soldering you're gonna have to do by being able to plug things in. So next we're gonna move on to the receiver. Now this is for your radio link. There are some small solder pads on here and I will show you guys how to do all that. It's relatively easy if you have somewhat of a steady hand. I always add in my own little bit of filtering. Because that flight stack has filtering, I'll only be using one of these caps. I'll also be using an inductor. That way I've got really clean power going to the flight controller, so we get no noise in the video. And last but not least, we've got all our parts, standoffs, hardware, everything comes with the kit. And all our carbon fiber pieces, the main plate, the arms, the sandwich plate for the arms, the top plate, which I already had put a piece of 3M style gel sticky. A couple more carbon pieces that work up front. And then he throws in a couple TPU prints here as well. Now these are for your camera. Different options for cameras, right? And then for your antennas. But I'll be doing my own prints for this, so we won't be using any of these. Let's move on to that build. So this is the basic layout of the frame here. So what we're gonna do, everything's gonna go on with a 2mm driver. So we're gonna take everything off because we're gonna secure the arms to the main plate with the sandwich plate. So I'll remove this. So the first thing we're gonna do is I'm gonna take an arm, move all these arms out of the way, set it up, now flip over the main plate. Now, these press nuts need to be facing upward. Your stack, or your flight controller, what we call it a stack, okay, is gonna sit right in the center here, on top of these. You must make sure you do this the right way. If you do it the wrong way, they're just gonna fall out. So, but I'm gonna flip it over now, and this just comes in place here. Now I'm only gonna use one screw for each arm in the beginning because then you can position it the way it needs to be. So we'll take the squash plate, we'll drop a screw through, we'll go ahead and put it through the arm. If it doesn't go through, no big deal, you will have to thread it in. There we go. And then as you can see, it's through there. Now nothing will get tightened down. If you've seen any of my videos before, guys, and you'll know, I always tell you snug things up at first. So just a little snug there. There's one arm. Then I'll take a second arm. And you got to make sure it's facing the correct way. So they'll line up with the next holes, and you got everything in there the right way. And they also lock together. They also lock together with this flat piece, which is nice, so your arms don't move when you crash, which I really like. He's also redesigned this a few times to make it a little bit more durable through the testing I helped him with. So I put it through its paces for sure. We have a new set of bando arms that will be coming out for it. When I use the term bando, I mean like an abandoned building. What we fly in. So you want to go ahead and make sure those line up in the groove here. We're not tightening anything down yet. Nice thing is, because these arms have a groove in them like that, here and here, they're easy to take in and out and swap out if you break one while you're out flying. So that's another nice feature of this frame. All right, so the next step, I've already done 2 ahead of time. You're gonna wanna put these 2 in. Now, if you are using a different stack than what we've got here, okay? This is a 20 by 20. You can also use a 30 by 30. It gives you both mounting hole options. If you're using the 30 by 30, you'll go ahead and use the longer screws so you can mount your stack. I'm using a 20 by 20. You would sometimes still use these, but because mine comes with that fancy case, it's just gonna bolt right down. I'll actually have to grab some hardware from downstairs, and I'll let you guys know the length of that if you were to decide to build one of these and go with the same stack as me. Okay, so you just, same hardware again. So it just fits through here. And again, because the arms can move here, is nice because it'll just always seat right in. And again, I've only just snugged things down. Nothing's tight yet. Now, I also recommend using Loctite on your build as well. On your motor screws, your arms regardless, you can use it, but definitely on the bottom screws as well. Mounting to these different standoffs, we're gonna wanna go ahead and use Loctite on those. I'm just showing you this. I will re-Loctite everything. This is just to show you how to build the frame. So now you can make sure these are nice and matched up in between the arms. That's where they lock. Nice and matched up. And then I'll go ahead and I'll go around and I'll start to tighten things down in an X pattern. Next, we'll take the long standoff. There's 2 different lengths. You got long and short. Now, depending on the stack, if you use this stack, you would actually have to ask Eric at Rotor Village to provide you with the standoffs for this stack. They're taller. He actually normally gives a smaller set. So we leave that kind of stuff up to you guys though, to pick what type of hardware you want to use. Now we'll go ahead and take the standoff and thread it down. It's knurled, I just grip it, give it a little tighten. Second long one. Again, guys, if you were doing this to build it right away, you're gonna wanna put Loctite on there, so a little dab of Loctite. I don't do it on the top. When we put the top plate on, we won't be using Loctite. Then you want to go ahead and take these longer screws that you use that go through the arms to go through these little pieces of carbon here he gives to reinforce the front plate a little bit better. So you're going to want to take those. Just take one at a time. As you can see the way it goes, it can look a little confusing at first, but that's how it should go on. And then again with the other side, same thing. So we'll run that through, and then we'll just put a standoff on, and I'll show you guys here. So now that we've got the base of the frame built, everything's pretty much installed except for the top plate, which will eventually have a GoPro mount and some more 3D printed parts on it. But let's move forward. and put the stack in. So the stack comes with instructions. Now, not every stack comes like this. This is my first time testing this. I just had to. It does come at a high price point. Now you get very well laid out instructions on what goes where and everything. You can also see it on the stack itself. Everything tells you it's USB-C, which is nice. Now, because this is pre-filtered and what I'm looking at here, I'm not going to need to actually use an inductor. I can only assume this was built right. Let's maybe take the top off and take a look at it and see what's under the hood here a little better. Because if I can use that inductor, I will. It's something I'm very keen on when it comes to building drones, is definitely having proper filtering with capacitors and inductors. It also will save your ESC down the road, getting into bad crashes and stuff that can overload and overamp things. You can run into blowing stuff up. I mean, it's inevitable, but don't get me wrong, this is one fun hobby. These drones take a beating, guys. These drones literally take a beating. Pop that top off. Okay, it does have, so you could take all this out and run it if you wanted to save weight. I'm not going to be. I'm going to keep it inside there. I'll probably just run a little bead. Oh no, it needs cooling. I won't do that. Now, I'm not conformal coating this build. You can go ahead and go to like New Tech Electronics, or there's all kinds of places. We don't actually sell it, but you can buy conformal coating and you can conformal coat here. Now, there is one thing you need to watch out. You want to put your plugs, plug them in to all the ports in a USB-C on something like this, as well as this. While you're conformal coating this, also with your boot button here, you don't want it getting in any of there, but you can waterproof your electronics this way. This build is not, if it goes in the water, I lost it, probably. So we're not gonna conformal coat this one. I won't be flying it in the winter. But I do see that it might be possible for me to use my inductor. I just do want to take a close look at the components on the speed controller and make sure I'm content with not using an inductor. Because what I like to do is take the power wire here, splice it, and I'll run this inductor so the power that's coming into my FC is really clean, translating the clean power through my radio link as well as my camera link. I know we're getting into a little bit of detail there, guys, but if I can figure out a way, maybe I'll have that pass in there. I'll think about that down the road, but for now, I would like to keep it inside the case. It's really nice. So we'll seal that back up. I really don't see a place to run it. I'll try it without the inductor. I will be adding one more capacitor. I think this was designed with LC filtering in mind, so we'll give it a shot. Let's just give it a shot. It is a very expensive stack, so for the price point, maybe you shouldn't need to add inductors and all that other fancy stuff I do with most builds. Now that we've taken a look under the hood of this flight controller stack, this is, I've never seen one come like this before. That's what really intrigued me. I thought, wow, that's neat. It's got its own capacitors built in, and you know, everything's all plug-in, which makes the build a lot quicker and easier. Normally you'll just have those two components together on some standoffs here. But yeah, let's go ahead and what you can do now is take your 2mm driver, because I had the 1.5 to open that up. Then these holes here, they got the cutout so the screw will go through. Then you'll just go ahead and get that through. And it's got tapped inserts on the bottom, which those are too long. We only need the short guys for this one. So we'll push that back through, get that screw out. And we're gonna use the short ones because I don't want to thread into the ESC or have any chance of that happening. That's perfect. Should just fit. The Rush is, the VTX I use is big, and I'm just looking and eyeballing, am I gonna have to use something smaller? Sometimes this happens in a build where you'll as this is like right on the edge of just fitting a strap underneath it. But yeah, that's pretty cool. I might not fit my VTX back here, so we could run into, and this happens when you build these things, I might have to rethink, but the VTX I use, I'm very, very stubborn. I've been doing this for a long time, and you kind of get stuck with what you like. Like even switching stacks and stuff was, it's hard. When you find what works, you like to keep it, right? And I found what works. All right, stack is bolted on. Next, we're gonna move on and install and solder our motors to the stack. Okay, so the next step I've taken, now this is up to you, you can just use electrical tape, whatever you want. Some people like to put something over to protect the wires. I'm taking this braided wire we sell here at the store, a nylon braided cable, and you just go ahead and slide it over the arm. And then I'll take one of the motors. We're gonna install the motors now and solder them up to the pads. So I'll just take a motor and we'll cut the wires to length after. And I'll slide those wires through the nylon braided cable. Then I'll go ahead and take some blue Loctite. Don't use red. Just drip a little bit on the bag there. What I do ahead of time is I'm gonna check and see the motor screws here, which length we're actually going to need. So I'll open both on this one. We're gonna see here, I believe it's gonna be the longer one. All right, so now that we have the stack installed, I've went ahead and pre-installed 3 of the motors with some cable management and heat shrink, and I'll show you how to do that with one of them. So first thing I'm gonna do with the first motor is take a washer. We're gonna put a little bit of Loctite here on this bag. Don't need much. And I'll take the screw and I'll roll it around in it. I'll put a washer on. Take my motor here. Get the screw started. Sometimes they don't just slide right through, you gotta thread them in. And then repeat this process for the other 3 screws. Great. Now, it's up to you. You can just electrical tape the wires down or do whatever you want, but I'm gonna use some braided cable management here, some heat shrink. And first I'll take the heat shrink, I'll cut one piece. I'll cut a second piece. So there's my heat shrink. I'll start by putting one piece on. I'll pinch this together so it'll go through clean. If it doesn't go through perfect, you can just slide it down. Then I'll go ahead and I'll take the wires. We'll get them inside there. Now before I slide it all the way down, I'm gonna heat the one side up. That way I can slide it the rest of the way down and heat the front side up. Go ahead and slide that down to where I want it. And then I'll go ahead and carefully try not to get your nylon braided wire if you're doing how I am. Next, I'll pull all this together with the second piece of heat shrink. And then this part can be a little bit annoying, but once you get it in there, it's all worth it. If you have a few that are hanging out, it's okay, just pull it down, pull it back over. These ones, and I'll hold the wires flat. Start from the back, front. You can use a heat gun too if you have a heat gun. Lighters work fine too, just be careful not to burn yourself. Now what I'll do is I'll lay the wire down, and I'm going to need the third one to be the longest. So I'll get a rough idea of where they are and then cut a little extra by going on an angle. That way when you lay it down, you'll be able to solder to these pads here. Now what I'm going to do is just strip off the ends of the wires. Next we'll move on to soldering and tinning everything. All right, so the next step we're going to do is we're going to take all these wires, make sure this is clean. We're going to tin them all. We're going to tin all the pads to the ESC, solder on our XT60 connector. So we've got the TS100 soldering iron out here with 2 tips. One I'll be using for the big battery connector, and one I'll be using for my motor wires here. So this has been sitting around this soldering iron. Just clean up the tip a little. Now I like to use paper towel to clean my soldering tip. Now I don't like to put it into a cold sponge because from hot to cold's not good for the tips. My tips seem to last forever. All I've ever used is paper towel. Seems to work great. Just don't flick solder in your eyes. So we'll go around here, tinning. Now guys, I'm definitely not claiming to be the best soldering guy in the world, but I definitely know how to not make cold solder joints and messy joints and things like that. So you don't want to be overheating pads, things like that. That's very important if you're ever building a drone or anything where you're soldering to electronical boards. You definitely want to be careful there. Not overheating things, using the right solder, you know, thin solder too. That's really important. I use rosin core, flux core, so it's got both in it already. So I don't need to use flux. Now that I've done that, we'll go around and hopefully Jaron can get you guys a nice close-up of tinning these pads. So I'll just go ahead and apply some heat to the pad and then bring my solder in. I'm gonna get a nice shiny ball. So hopefully Jaron can zoom in on this and we'll okay, we'll turn it around. We'll do this on the other side now. Same thing. Solder on the iron. As you can see, mine smokes a lot because of the rosin core, flux core. If you have some type of a fan to pull that stuff away from you, it's probably best. And there we go. We've got all of our pads soldered. I'm going to go ahead and pre-tin the battery lead pads now. There's one. Okay, got those tinned up. Lost my paper towel for keeping my tip clean here. All right, next I'll go ahead and take my pair of tweezers out and I will start soldering on my wires for my motors to my speed controller. You want to make sure the solder flows together. Nice shiny ball of solder. That's what you want. We don't want any cold solder. Now, be careful. You're heating these pads up. Don't let that, don't pull any strain on it and risk letting the glue go on these pads on these boards. We don't want that at all. Just hold it in place till she dries. And you can kind of position them afterwards. Now just hold it there where the solder's cooling. I'm not going to bend those into position yet because I don't want to put any strain on those heated up pads. We'll go ahead and continue this the rest of the way around. Okay guys, so the next step we're going to take here is we're going to solder our XT60 to our flight controller, as well as an additional capacitor there to help with electrical noise. What I did ahead of time was, just not to bore you guys, they're just plugins. I ran some of the wires, so the one for the video transmitter is already ran underneath, just to kind of avoid having to show you guys some of the boring stuff that's not necessary. So the first thing I'm going to do is I'm going to take these wires, I'll rest them on top of my soldering stand here. Now what I'm going to do is I'm going to give them a little bit more tin, some fresh solder here. So we've got a bigger tip on now because of the size of the wiring. So we've got some fresh solder on. Always good to have fresh solder. There we go, some fresh solder. Now, what I am going to do is kind of be doing this on a bit of an angle, so I'll take the first one here, get it in position. Let everything flow nice and even. And then I'll take my ground, get my ground in there, make sure it's not touching anything, and same thing. Not in there enough, so I'll redo that. Want it to be nice and clean, no matter what, that's important. Make sure it's nowhere near that positive. It's a little tight in here with this thick wiring, but we'll get it. There we go, and I'll be able to tuck that and pass that up to the battery once it's all done. Good solder joints. Double check everything. Looks good to me. Okay, double check everything here. Still gonna be good. With our VTX here, we'll check that wiring, pull it in, VTX in, and my RX will sit on top of the VTX with the capacitor over top and a little bit of foam. It should be good in between to protect them from damaging anything. So now what we're going to do is I've cut off the leads off of this capacitor. I'm going to go ahead and solder on 2 wires to it. Okay, the line is always your ground. Okay, so I'm also going to color coat the heat shrink I put over them as well. So we'll go ahead and solder the first one on here. Just clean up our tip a little. Got a paper towel. We'll go ahead and put a little bit of solder on each one of these. Okay, A little bit of tin on the wire itself. Okay. I'll go ahead and solder them on. You should get a nice flow and some shiny solder. It's on there good. Second wire, same thing. Nice little bit of flow there. Now we'll take a piece of black heat shrink and slide it down over. Take my lighter here. Just to make sure the capacitor is nicely covered there. And I'll take the red for the positive, cut a little piece for that. And same thing. Now I'll just quickly take a look where I want this, because these wires will be up and out of the way. The capacitor will be sitting right here. So just for wire length, really. We'll cut off about that much off each one. Strip it back. And we'll tin those as well. And now I'll just carefully solder this on to the positive. And I'll get my tweezers out for the ground. Give it a little tug, make sure they're not coming off. And once it's all said and done and my receiver's in there, we'll put a little bit of foam on this and just one run of electrical tape around to hold them all into place. Okay, now we've got our capacitor in, our VTX is in. Next we're going to stick the VTX down so it's in place where it's going to stay. And then we'll solder our RX on and install our camera. We're almost there, guys. So now that we've installed all of our components, VTX, capacitor, battery lead, motors, flight stack, which is an electronic speed controller, and a flight controller, which is all inside this box, you can go ahead and take a look at this. This is the RX. Now what I've done is I've pre-soldered it up ahead of time so you guys don't have to get a tutorial on soldering all over again, but I will show you what's what here on this Crossfire Nano. We've got ground, power, blue wire is TX, then RX. So I've went ahead and pre-soldered all that up. And because they're through holes on here, I'll just check the other side to see if the wire came through a little too much. And I'll snip a little bit off here so we don't have too much coming out the end. Now what I want to do is take my 3D print. So this is a flexible TPU print. I've printed up ahead of time on an Ender 3 with a micro Swiss direct drive. Now, in my opinion, it's a must when you're 3D printing TPU. It's not 100% must, but you're going to be printing really slow if not. So I'll go ahead and I'll pre-install my antenna from my radio system, which is the RX, like so. And then I'll go ahead and pre-install this as well. And this is going to take a couple of screws, and I'll screw them through there, secure it down, and we'll get it all in place here. Okay, so we went ahead and took the provided screws and washers from the camera and took the camera 3D prints we had done, and we're going to go ahead and install that onto the drone now. Very simple. We'll keep our 1.5 driver out, that way we can tighten it up once it's in place. We'll go ahead and take our camera plug, plug it in, and then this is our camera control plug, which comes from the wiring harness that they give you with the flight stack. And we go ahead and plug that in so we have our camera control. We'll slip our camera on here, put it into position. Now I fly a 45-degree angle on my camera. So I'll position that now and then tighten down so my camera holds in position correctly. I'll remove this bit of zip tie I put in to hold the wiring down and out of the way of getting snagged on trees and stuff. So we'll go ahead and clip that now. And now we have our camera in place. We'll go ahead and we'll mount our top plate, as well as let's throw on our video transmitter antenna, and we'll thread that on there. It's the new Fox ear. I think they're like 2.3 or something on the gain. So it's an extremely clean build. I'm actually really liking the setup so far. Now, go ahead and get our GoPro mount, which was printed here at 3D Printing Canada. I will go ahead and slit some screws through it here. I'm using some longer screws as well for the GoPro mount, make sure it holds on really good. Go ahead and pop those in. And then we'll take our top plate. Get those in there, and I'll actually take and put in the back screw first, which isn't going to require such a long screw. Take that top piece, because this GoPro mount has its own little nut underneath that it tightens down to. So I'll go ahead and thread that in first. Tighten down, and go ahead and put the top plate on. And I'll run in these two back screws. I never put Loctite on my top plate because if you ever have to take it off to repair it and stuff, it's normally the bottom you got to worry about for Loctite. Go ahead and get that top piece secured. I'll take and push back the GoPro mount just a little bit so I can get in there. The knurled standoffs are nice because you can grip them with a pair of pliers. Make sure everything's nice and tight. I just like to go around after the build and make sure nothing's gonna come loose. That's good. And there we have it. So the drone is now built. All that's left, we're going to need to do the programming. So I'll take you over to my computer and show you how to program and bind the receiver, set up our video channels, all that. Then we'll throw some props, some battery straps on it, a GoPro, and we'll take you out to the field, guys, and let you see how it flies.
All right, guys, now that we've got EmuFlight open, you might be using Betaflight or something else. You can go ahead and plug in Betaflight, EmuFlight, same thing. Once you get your COM port, I have auto connect. Always enable expert mode. Now we're going to disconnect from here. Now, if you're going to flash, you go to update. You got to put your flight controller in boot mode. So there's either a button or two pads you have to short out. Check your your flight controller wiring diagram. Then you go ahead and firmware flasher. You choose your board. I'm using an Axis board. I don't know if I have a special target that was made for me, and it doesn't look like they put it in here yet. So, oh, they did. He did. After we finalized it, he actually ended up putting it in the list. So you go ahead and you select that. It'll give you the latest version. Pick the latest version, load firmware online, and then flash the firmware. I've already done all that, so we're not going to bother. We're going to go connect. We're going to connect. The first thing you want to do is your ports tab. Wherever you had soldered your UART to, in my case it's to UART 5, the serial RX is enabled. Now my smart audio to control my video transmitter is on UART 2, so you go ahead and select whether you're using Tramp or RunCam protocol, whatever you're using, you go ahead and select it. Then you hit save and reboot. Once it reboots, you go into configuration. Now, you want to go ahead and set up your motors to DShot 600. This is up to you. You want to have a smooth idle percentage, so if when you arm, your motors are kind of going boom, boom, and not just spinning smooth, you want to up that. Okay, because I'm not using any of these, I shut them all off, leave it at 8K. We're not doing 32 kilohertz. Now, if your gyro's rotated, this is the section to do it all. I'm not going to show you guys how to set up your accelerometer for like beginners and stuff. I don't recommend flying like that. It adds band-aids. So we'll move down here. You can put in your craft name so you can see it on your OSD, your camera angle, all that, things like that. So most people be serial based. This is where you pick your type of receiver. Okay. And then mine is Crossfire. They have a huge list here. Of, you know, Ghost or IRC, stuff like that. But I'm using Crossfire, so we select Crossfire because it's 900 megahertz long range. Those are the only things I keep on here. There's more tutorials to show you how to do that, but you really only need air mode and OSD, stuff like that, dynamic filtering. This is to set up a beeper if you lose your RX, so your motors will beep unless you have a buzzer on there. And then I just leave all this stuff enabled. And you go ahead and hit save and reboot. This is all on board, so you don't need to set any of that up. You can set your fail safe here, which I do in my Crossfire, so we're not going to go through that. It's not necessary. This is the PID tuning where you can set your rates and your filter settings. Now, I'm not going to go through all this because there's tons of tutorials and it would take us way too long. The video would be way too long, but this is where all your PID settings are. Most of you will just be setting up your rates here. I recommend Expo right here for beginners. You know, things like that. All right. So then the next we'll go to the receiver tab. This is important. In my case, none of this is moving right now unless I turn my radio on, but you guys want to go ahead and make sure once it is on that it's working correct. So you want to make sure that I think I have 5-volt pass through on this. So I'll show you guys the 5-volt pass through. So you just go ahead and I'm going to turn on my radio here to show you guys what's up. Okay, now you can see everything moving on my sticks. My RSSI channel always goes to aux 8. Yours might be different. Again, you're going to have to watch like Joshua Bardwell or somebody to do a full complete setup video. But in here, mine's TAER123 to make everything work the right way. As you can see, aux 4 is the 8th channel down though, but it's an auxiliary channel. So we go to aux 8 because if you count from the top, aux 4 is actually aux 8 over here. I know that might be a little bit confusing, but all right, moving on to modes. This is where you have to select your mode. So you can just click on out of range and then you can flip a switch and see it added the range to aux 1, but I'm going to remove it because I don't need a fail-safe switch. We're not doing GPS recover. None of these are going to need to do this unless you know you've got deadband in your radio, which if you're doing this new, you won't. We're not setting up anything with servos. This is the motors tab where you can test to see that your motors, make sure your props are off. You have to agree to it to be in this stage. And then this is where you can set up your OSD and all the positions and things you want on. You just click the box and you can literally move these around. I'm actually going to save that because I don't like that there, so we'll save that there. Don't like it in my face. And then CLI, this is where 3D printers are kind of similar. This is like having Pronterface to change firmware things. So you can add anything you want into here. Just make sure you know what you're doing before you do it, guys. I know this tutorial wasn't super intuitive, but the whole point of this video is to show you guys, you know, what you can do with your 3D printer and how I use it for my drone hobby. Now, if you do have any questions or get stuck on anything, you can always send us a message or leave us a comment, and I'd be more than willing to help, guys. So keep that in mind. I hope this part was a little bit helpful. You might choose to use Betaflight or Flight 1 or KISS or something. There's tons of tutorials out there for how to set them up. But if you guys do have any questions, feel free to give me a comment in the comment section, and I'll be more than happy to answer them. All right, guys? See you in the next part.
All right, guys, I hope you love the flying, the build process, the setup. And if you are interested in building one, you could always reach out to me here at the shop. I can send you over to Rotor Village. So we're gonna throw a big shout out to Rotor Village for helping sponsor some of this video. You can find all these parts. This is his custom frame he sent me for testing, okay? As well as, I did all the 3D printed parts, obviously, out of a glow-in-the-dark TPU from Spectrum. You can get a nice little close-up on that. And I do have to give one other big shout out on this. You guys are gonna laugh at the name. On Facebook, his name is Boo Earns. So shout out to you, Boo Earns. He actually did the coding for this specific flight controller because I like to use what's called Emu Flight, and there was no code for this brand new flight controller in stack out yet. So Boo Earns, thank you. This video would not be possible without you and the help from Eric over at Rotor Village. And big shout out to the guys here as well, Chris, for letting me do this video. It was absolutely a blast. See you in the next video.